Hey everyone, this video is going to be just a little bit more practice on finding these reciprocal trig identities, meaning we're going to have like a fraction or something and we have to use our reciprocal or our Pythagorean identities, which we talked about in the last video. And you have this nice chart here which has them all laid out for you. So we're going to be using these trig identities to reduce these expressions to a single trig function or a constant with no denominator. All right, so very similar to the packet ones that we did last week. Just some further practice on that before we get to any more difficult ones. So as a general strategy, I said in the last video with this, is the best thing you can normally do is just to turn all functions into sines and cosines if possible. That's generally a good strategy to accomplish your task. So in this one, we've got a cosine on top already, so we're just going to leave that as cosine of theta. The bottom is cotangent, so let's replace that, but let's go figure out what's the best thing to replace it with. We've got some options. This one is a 1 over tan, which is not good because we didn't really help ourselves at all. This one, however, is a cosine over sine, so we do want to choose that one because we want to get sines and cosines. So then we get cosine of theta over sine theta. It seems like we made it more complicated, but it's not really the case because we got all sines and cosines. So now this is called a complex fraction. It's a fraction within a fraction. So we're going to keep the top the same, cosine of theta. And you could even write that as cosine of theta over 1. And we're going to multiply that by the reciprocal. So we flip the bottom and multiply. So times sine theta over cosine theta. Those cosines are going to cancel, which is what we're hoping for, and we're left with just the sine of theta. So we simplified it to a single trig function with no denominator. Use a little theta symbol down here. Okay, let's try the next one. So this one is a multiplication. Still going to work the same way. I would still use the same strategy that we've been talking about. Let's go ahead and try to replace both of these with sines and cosines. So with cosecant, you might remember with that one, cosecant 1 over sine. So let's go ahead and replace it with that. So 1 over sine of theta. I'm going to put it in parentheses like that. And then tangent is sine over cosine, right? So times sine over cosine. And we'll see we get a nice cancellation here diagonally. We get 1 over cosine of theta. So that's good. However, we don't want to leave it like that because we're not allowed to have a denominator. So there is another trig function that works for that, 1 over cosine, and that is right here, secant. Remember, secant and cosine are opposites, and sine and cosecant are opposites. So secant of theta is our answer. And we'll go ahead and type it in. Boom. All right, let's go through maybe 1 or 2 more. So same strategy here. We're replacing everything with sines and cosines. Cosecant is just 1 over sine. Right, as I just said, those are reciprocals. With the sine, we don't need to replace that because it's already in a sine or cosine. We then see that those are going to cancel, and so we're left with just 1. That's not a trig function, but a constant is even better. So our answer will just be 1. Just make sure you don't type that in as 0 because you still got that imaginary 1 there. All right, let's finish out with this one. Cosecant, think about what that is. Well, that's 1 over sine of theta. If you need to look these up, feel free, definitely do that. 1 over sine theta, and then we've already got sine theta on the bottom, so we'll keep that as is. With a complex fraction, we're going to keep the top, 1 over sine theta, times we flip the bottom and multiply. So this is kind of like sine of theta over 1. So we actually flip and multiply there, 1 over sine of theta. Now don't just assume these are always going to cancel because you're going to see here they don't cancel in this case. So don't just assume they wipe each other out. And we get 1 over a sine theta times a sine theta is a sine squared theta. Okay? So we're not done yet, though, because we still have a denominator, and we have to have no denominator. All right, now think about what 1 over sine is. Well, that's cosecant, right? So we can replace this. The squared is okay. It's just going to hang along with our cosecant. It's just going to be cosecant squared theta. The reason that we can do that is 1 is actually kind of like 1 squared as well, because 1 squared is 1. So you can actually think of this whole thing as like 1 over sine theta squared, if you will. And so we can just flip it inside of it and then square each individual ones. Right, and it's the same thing. All right. So this same thing as the cosecant squared. And it works out to give you that. So just note that you can do that, but that's the math reason behind why you can do it, is because we have a 1 up there, and 1 squared is the same thing as just 1. All right, so let's go ahead and type that in. And remember, when you type these in, you want to square it right after the cosecant or whatever, and then do your theta. Is how we type squareds for trig functions. Actually, let me do one more just to make sure you've seen every scenario here. All right, secant squared theta and tangent squared theta. All right, let's see what the best thing to do here is. Secant squared theta and tan squared theta. I'm going to go ahead and replace these with sines and cosines. You could also, maybe there's some other way to do this, like secant squared theta. You could replace that with 1 plus tan squared theta, but I think it's just going to make it more confusing for you. So I would just stick with the general strategy of replacing these with sines and cosines. So if we do that, secant squared theta, remember secant is the opposite of cosine. So that's actually equivalent to 1 over cosine squared theta. Okay, so I would go with it in that way. All right, and then with the bottom of our fraction, the tangent squared, well, tan is sine over cosine. So this is the same thing as sine squared theta over cosine squared theta. We just square everything if it's squared. From there, we'll keep the top, 1 over cosine squared theta, and we flip the bottom and multiply. So that becomes cosine squared theta over sine squared theta. We can then cancel because they're diagonal. So we get 1 over sine squared theta. And then to get that out of the denominator, we just think, well, what's the reciprocal of sine squared? And that's cosecant. So this is equivalent to cosecant squared theta. Cosecant squared theta. I think that should be all the scenarios you have. Again, in all of these, you might be tempted to replace that secant squared with something else, but I would just always stick with the strategy of converting them to sines and cosines. All right, best of luck with that, and reach out to me if you need some help.